mind me.
I have to pee so bad. I'm doing this.
You're gonna be okay, baby. You're gonna do good. So cute. Look at this Mrs. Secretary going in. What happened?
Where's my Zoom invite?
Oh, baby. Is it in your email?
I'm in my email. I just saw it earlier. I didn't delete it.
What?
I found.
Good. What? Baby. You're gonna be okay. You're gonna be okay, baby. You're gonna do good.
How is it already a mess over there?
Oh, Tommy? He works fast. Hey, I didn't touch his side of the room. I cleaned my side of the room. I vacuumed my side of the room too. Okay, okay. Hey, at the end of your Zoom thing, I'm gonna tell the guy, I'm gonna say, hey, let my girlfriend pass. And then he'll have to do it. I mean, hey. You don't get.
Okay, I have to study for like 10 minutes.
Okay, I'll mute.
Thank you.
Love you. Don't mute. You don't mute. Good. Love you.
Love you.
I love you.
Right, we need our standard deviation for y. We need our standard deviation for x. Okay, we're going to need to calculate our correlation. We're going to need to calculate b, and then we're going to need to calculate a. Right, and so these are going to be the key components that are going to be used in order to actually write correlation. We need our standard deviation. Actually, go about calculating this line ourselves. Well, if we recall, we need a few things. Right, we need our standard deviation for y. We need our standard deviation for x. Okay, we're going to need to calculate our correlation. We're going to need to calculate b, and then we're going to need to calculate a. Right, and so these are going to be the key components that are going to be used in order to actually calculate out our regression line. So, if we recall, if we want to calculate the standard deviation of something, we just use this formula here, the standard deviation formula. We select our column of interest. Remember, we are treating height as our response variable, so this is what we're going to be calculating the standard deviation of y for. Okay, same sort of thing if we calculate our standard deviation for our x variable, right? And then if we're interested in calculating the correlation between the two, we use this core L function, and then we will just choose our first column and then our second column of the data. Okay, so really quick, easy calculations here. We get pretty much 5, 3.4, and then 0.71. And just to verify that this is correct, if we go to the applet ourselves, we see that we have our R of 0.711. We have our standard deviation for our y of 5, and we have our standard deviation of x as 3.45. Okay, so Excel is pretty much going to be giving you the same numbers. I'll actually go ahead and change this to our squared. So if we just take this value and square it, then we get that, once again, we have this idea that 50.6% of the variation in height is going to be explained by foot length. Okay, so once again, in order to calculate A, we need to calculate B first. And if we remember from our calculation that B is going to be equal to our correlation, right, times our standard deviation of y. divided by right times b is going to be equal to our correlation, right, times our standard deviation of y divided by the standard deviation of x. And we notice that gives us 1.03. Once again, going back and confirming this with the applet, we have 1.03. Okay. Now, if we recall, one more thing that we need to calculate for a is that we actually need to have what the mean of y is and what the mean of x is. Okay, and so this can be easily accomplished by using the average function. Just selecting our column for y, and then if we calculate the average of our x variable, then we see we get 67.75 and 28.5. Once again, wanting to confirm these numbers, these are consistent with what is shown in the applet. So recall, when calculating a, we are going to have y bar minus our slope times x bar. Okay, that's going to give us 38.30 for this example. Going back once again, consistent with what we found in the applet. So you can be pretty confident that these calc again, that's going to give us 38.30 for this x bar. Okay, that's going to give us 38 times x bar. Okay, that's going to give us 38.30 for this example. Going back once again, consistent with what we found in the applet. So you can be pretty confident that these calculations and formulas that we're using in Excel are going to hold up with what we're seeing from the applet. Okay, so this gives do a quick and easy version of your formula, right? We have our A, we have our B. Now all that we need to do is that we need to get our y hat, or our predictions, right? And so this is just done by actually implementing our regression formula. Okay, and if you remember, our regression formula is just the form A plus B times X. Now you can just always leave this as a plus here because the sign change is going to be associated with B to begin with. So remember, this is just a general formula, but we actually need to include cell references. So we need to include what our A value is. Now remember, we're going to be using the same A and B for all of our y hat calculations. For any predicted value of y, it's going to have the same. Intercept, and it's going to have the same slope. So we need to make sure that we have these dollar signs in to make sure that this A value doesn't change throughout our calculations. We're going to do the same thing with our B value, right? And this B value, our slope, is going to be multiplied by whatever our X value is here, or the foot length, okay? So once we hit enter, we see that if we have an X value of 32, right, if we have a foot length of 32 centimeters, it predicts a height of 71.36 inches, which is not too far off from the height that was recorded in the data. But remember, all of these are going to be calculations, right? These are all predictions. They're not necessarily going to be equal to what was observed in the data. That's where the residuals come into play. So if we put this little box down here on the bottom right, we see that we get our y hats for all values. Now, another thing we might be interested in doing, obviously, is we want to get our residuals. So if we want to get our residuals, we remember that is always going to be our y variable minus y hat. And that provides us with 74 minus 71.36 y variable minus y hat. And that provides us with what our residual value is. So 74 minus 71.36 is going to be roughly